Kau asal Dek nak apa kata aku dekat nombor aku? Buka. Mana nombor aku?
John.
Kau kasut ni tengok.
Ada. Kita tengok dulu. Apa ni? Main.
Sini.
Belajar basic. A1 dikosong A1 dikosong kosong 1. So dia ambil 1 kat sini, tak ada 2 kat sini.
Objective and purpose. This project is to develop an IoT-based smart door system that combines many IoT devices and electrical components to improve security and safety environment for user. This system can be controlled by both manually by using a RFID and remotely using smartphone through the Blink application. User can also monitor the system through the application and can get a notification alert. Arduino Uno is a microcontroller board based on the ATmega328P microcontroller. For this system, Arduino Uno was used as the connector between other electronic components so that the system will work perfectly, such as buzzer, LCD and LED. It's also connected to EXP8266 to connect to the Wi-Fi by sending input and output to it. RFID reader is a device used to read information stored on RFID tags. It can be transmitted through radio wave. For this system, RFID was used to lock and unlock the door manually using RFID tags. This device was also connected and sends an input to the Arduino board in order to unlock the door or lock the door by the user. Servo motor is a rotary actuator or linear actuator that allows for precise control of angular or linear position, velocity, and acceleration. For this system, servo motor was connected to Arduino board and sends an input to Arduino board whether it moved to unlock the door or lock it. ESP2866 is a low-cost Wi-Fi microchip with full TCP/IP stack and microcontroller capability created by Expressive System. In this system, ESP2866 was used to connect to the Wi-Fi and allow this device to communicate with the cloud and the Blink application. This device also received data from Arduino Uno and process it, then sends it to the cloud and the Blink application. LCD12C modules. The LCD12C modules is an interface adapter used to simplify the connection and control of an LCD screen using the 12C communication protocol. In this system, LCD12C module was used to display the status of the system, whether the door is unlocked or the door is locked.
So, next part is gateway. The first gateway is that Wi-Fi connection. So the ESP8266 Wi-Fi module can connect to local Wi-Fi networks, allow it to communicate with other devices and the internet by requesting an IP address so that it can connect to the network. We need to put our network's SSIDs such as name and password. This can be done through the microcontroller or the program of the ESP8266. Next gateway is that communication with the Blink application. To connect with the Blink application, ESP8266 use Blink libraries such as Blink Simple ESP8266.h and Blink_off_token. ESP8266 can communicate with the Blink application by using the library. It enables to control and monitor our IoT devices from everywhere with internet connection. Next is interface with IoT device. ESP8266 receive input and read from the IoT device through Arduino Uno board. For example, RFID reader detect RFID tag from the user. This can control servo motor, buzzer, LED light to unlock the door or lock the door based on the user input. For the cloud, it has data storage. Data storage can keep all information of our IoT smart door system. For the platform, we use Blink application. This application can retrieve data and store data from IoT device. We can gather the data and info to analyze. This system use notification alert to alert the user for any critical thing, whether the door is locked or unlocked, as the status of the door through the Blink application, email, and smartphone. This allows users to monitor the system from anywhere. For real-time monitoring, users can look through their mobile app to see the current status of the smart door system. For example, LED, servo, and door. You will also receive and able to check the notification alerts and interact with the system through the Blink application. For data analysis and decision making, we set the system to send a notification to the user through Blink application so that if the door is unlocked for more than 10 seconds, it will send a warning notification to remind the user to close the door, or maybe possible intruder may come through the door.
The coding is libraries for certain components such as servo, LCD, TFC module, and RFID to function. The coding is defined for each component's pin was set on the Arduino board. The main loop function is for the data from ESP8266 coding. If the coding receives 1, then the system will unlock the door. However, If the coding receives 0, then the system will lock the door for remotely control. The user scans the RFID text at the RFID reader. If the coding receives 1, then the system will unlock the door. However, if the code receives 0, then the system will lock the door for manually control. This is coding when the door is locked. This is coding when the door is unlocked. This is coding for LCD and the buzzer was set for them to function in the system as it should be. This coding is for device Blink setup from the Blink application. Also, it has libraries coding for gateway functionality. Lastly, it is a coding to connect ESP8266 and the local network by enter the SSID and the password. This coding is for the notification when the door is unlocked or the door is locked, and real-time monitoring coding, LED light, servo, and door. This is the coding to set the servo motor whether to unlock the door or lock the door. The function of this coding is to make the ESP8266 stay connected to the Blink application in order to allow it to send and receive data.